Good morning. Then I will speak about brain control. It is a framework based on artificial intelligence for human-machine interaction. Then I will start with a funny video. Imagine you were able to control object through your mind, okay? And see this. Okay, this is an helicopter toys controlled by the thoughts. How it is possible? Through EEG sensors like this. You can wear it and we can detect the brain waves on our brain. And we can recognize thoughts related to the movement. Push, pull, right, left, up, down, and so on. It is possible thanks to machine learning and artificial intelligence techniques that allows us to map the electrical activities on our brain and recognize in real time this kind of thoughts. Okay. In the same way, we can control any kind of an electronic device. Here you see another toys. It is not flying. It go on the stair, but in the afternoon, I will show also a telepresence functionality. We will control from here to Italy a robot through the thoughts. The idea is to provide patients with severe disabilities, very severe disabilities, patients in locked-in states, complete locked-in states, completely paralyzed, like in apparent coma, to control the environment and the electronic devices. But our first goal has been the communication for these patients. Patients with ALS, neurodegenerative disease, ischemic or traumatic injuries. 3 million people worldwide, completely paralyzed but cognitive aware. What we developed is a sort of mental joystick that allows them to control a communicator, an augmentative alternative communicator, wheelchair control, home control, and so on. Look this video.
Okay, now I'm going to give the no. I'm not well. I'm not well. Bravo papà.
La mamma, la mia mamma, si chiama Paola. Ottimo. Tua mamma abita in una casa grande?
In the video you have seen many patients with very severe disabilities, completely paralyzed from months or also years. The The most advanced patient we had, it was from 6 years completely paralyzed. Then we provide them this capability to interact, to communicate through the brainwaves. Okay, we start with a very simple user interaction, yes, no, don't know. Then we go through a sentence finder, then through the keyboard. It takes a training, a calibration of around 40 minutes. It is not so short, but not long for patient in this condition. Then, thanks to this patient regain the capability to say, okay, I'm sick, or I love you. They start interacting with the family member, with the doctors, and so on. But as I mentioned before, what is brain control? It's a framework for human-machine interaction. This means that of course, the brain-computer interface that is based on EEG sensor is the most advanced functionalities. It is a very news for the healthcare sector. But indeed, we can use any kind of biofeedback. We can also use, and maybe you know about this, that already exists from many years, the possibility to control through the eyes, through the eye gaze, an augmentative alternative communicator, but also through the voice, through small gesture, and so on. We can manage many kind of inputs and allow the patient, considering his capabilities, to interact and to control many kind of device. Then here you see an overview of the full platform. Here on the top, the BCI mode and the sensory mode. In the sensory mode, we include all the kind of sensor that are different from the BCI and then the EEG. And on the left, you will see the functionalities. Augmentative alternative communicator, home control, telepresence, cognitive assessment is one of the steps we are working on, is to allow doctors to use brain control as a diagnostic device in order to detect the cognitive level of the patient that is completely paralyzed. Then robotics and IoT. In the afternoon, we will show the remote control of a robot that will be a sort of alter ego of the patient, a sort of avatar of the patient. The patient that is on his bed cannot move, and through the robot interact with family members and friends and so on. Then we first focus on complete locked-in state patient, then locked-in state patient, severe disabilities, and we also will target patient, people, elderly people, and also we can propose this platform for automotive, industrial application, and so on. Then we first focused on communication. The brain control BCI EC is our first product that we certified as a medical device. Then we have working prototypes of all the other functionalities I mentioned to you. The BCI EC is made by grids and virtual keyboard, focused on communication. Then, from the input point of view, we can manage EEG sensors, eye tracking bar, camera from the tablet, gesture, touch, and so on. In the same way, we can train, we can calibrate the device in order the patient to personalize his proper way of interaction. Then the user can start using all the functionalities available on the software. Okay.
One thing. Do you have any devices and gadgets here?
Yeah.
And I am sure the people want to see how that function, that gadgets. Okay. After, if you want, you have
Yes.
a bit time to that.
Of
that-
course.
Explain that devices. Okay.
Yeah, yeah.
Thank you.
Of course, we can also, maybe we have not so much time in this moment during the talk, but after the talk I can also show you how this works, and I can also train for you a profile and then allow you to test the control of one of our device. Of course, we validated the system with patients and healthy people in order to analyze what is if there is some problem during the training, during the calibration, and after more than 500 tests we have performed, we can say that if the user is cognitive aware, then for example, if one of you will test and will start the training, we are sure that 100% that training will be successful. And this is a very high results, in particular for the BCI user interaction. It is the first time that a BCI interaction reached this level of usability and robustness. Then we received a lot of award recognition at international level, and we also started selling the first product and also allowing the patient to obtain reimbursement from the national healthcare system, starting from Italy, then now we are starting in Germany. Okay, this is. If you have any question or if someone want to try, I will be happy